Morning, guys. Happy Wednesday to you. Today we're going to be going over landscaping, how it's used, the different types, and the definition of most of it. During the course, we would normally actually go out and survey part of the Atkins school lot. We're not able to do that today, but it's still important that you understand the definition of it, what it's used for, and things of that nature. So I'm not going to go into extreme depth because you're not actually going to do this, where otherwise you would have needed to understand this and we would have taken about 2 days to actually go out and do that. Okay, so the definition of land surveying is any service of work the adequate performance of which involves the application and special knowledge of the principles of mathematics, the related physical and applied sciences, and the relevant requirements of law for adequate evidence to the act of measuring and locating lines, angles, elevations, natural and man-made features for the purpose of determining areas and volumes, for the monumenting of property boundaries, and for the plotting and laying out of lands and subdivisions thereof, including the topography, drainage, alignment, and grades of streets, and for the preparation and perpetuation of maps, records, plots, field notes, records, and property descriptions that represent these surveys. Why is that so important? I'll tell you why it's so important. In the midst of all of that, when your neighbor gets a bulldozer and for the weekend and starts digging on his property, and now all of his water's running towards your basement, going back to the topographic layout of that is the first thing they're going to look for this. Some famous land surveyors: George Washington, Surveyor General in Virginia in 1749. Thomas Jefferson, County Surveyor for Albemarle County, Virginia, 1773. Lewis and Clark, the expedition to explore and survey the West. Daniel Boone, resolved Kentucky land disputes. Abraham Lincoln, surveyor in Illinois when elected to state legislature. Land surveying, the science of determining the relative positions of points on Earth's surface. Two different types: geodetic surveys and plane surveys. A geodetic survey is based on the true shape of the Earth. The true shape of the Earth is not a sphere, but it's an irregular ellipsoid shape. Many models of the true shape of the Earth exist. One model, the geoid, is a model of the assumed mean sea level, which is dependent on the gravitational forces around the world. The Western Hemisphere geoid is shown in the computer-generated model on the right side here. The yellow and orange areas are further from the center of the Earth than the blue areas. The geodetic survey uses the geoid to another similarly shaped model as a basis. These surveys are performed with great precision and are used to establish highly accurate control networks that provide points of known position throughout the U.S. and the world. Plane survey assumes the Earth's surface to be a plane or flat. Not to be confused with flat earthers, though. More common than geodetic surveys, precise enough for small-scale surveys in limited areas, such as a construction site. And it's used to determine legal boundaries, construction surveys, and small area topographic or control surveys. Different types of surveys: control survey, topographic survey, property survey, site survey, and construction survey. Control surveys are used to establish the latitude, longitude, or elevational or reference points that can be used for other types of surveys. The image here is published in the Seminole County Geodetic Control Points document of 2006, which provides a description of the location of each control point in addition to the latitude, longitude, or the elevation. These control points can then be used as a basis for topographic, construction, and other surveys. The photos show survey crew members setting survey marks during the control surveys in Alaska. The black and white image was taken near White Pass, Alaska in 1936. The color photo is a more recent shot of crew members mixing cement to set a mark in a rock in southeast Alaska. This is an example of a topographic map for the area surrounding Stowe, Vermont. The contour lines indicate lines of constant elevation. On another really cool topic that's off of CEA, but still relevant, is you can take these topographical survey maps now, download them to an STL file, and 3D print them, which is something that, I've got a huge interest in and I think is super cool. Back on topic though, not to digress. This is an example of a recorded plat created from a property survey near Mount Pleasant, South Carolina. My sister lives there. Property lines are located using a length and a bearing angle. This site plan shows both the property lines and contours from a topographic survey. Examples of construction surveys include staking a line and grade for a foundation, a fence, or a road. In the picture here, the string lines, I don't know if you can see them going from left to right there, were laid out based on a construction survey. Notice the surveying equipment to the right in the picture used to ensure that foundations are poured to the correct elevation. Why is this important? Because if the road height seems to be the same height as the house, but it's off by an inch, water flows downhill. You do not want your basement or your elevation to be lower than that level. National Spatial Reference System, the NSRS. It's a common set of reference points for all surveys. It includes a horizontal datum for collection of points of known latitudes and longitudes, vertical datum, collection points of known elevations, and BMs, benchmarks, permanent mark that establishes a point of known elevation. The top example is a picture of the horizontal datum marker, and the bottom shows a benchmark. You can locate these on reference system datas. Information on datum points are available at this provided website here, along with many other ones now too. Paid sites, paid systems are much more elaborate and used for larger construction companies as well that get updated on a regular basis. You can search for the information on those reference points on the National Geodetic Survey Control Mapping System service for free though. This map shows the area near the Keystone Library project in Noblesville, Indiana, and the red points are datum reference points. The Keystone Library project, by the way, is the capstone Revit project that is normally done in the Project Lead the Way Civil Engineering and Architectural course. Different type of optical equipment. It requires a visual line of sight. A theodolite measures vertical and horizontal angles. And a total station is an electronic optical surveying system. A level measures vertical differences in elevation. The theodolite measures vertical and horizontal angles. A total station is an electronic optical instrument that combines both. Automatic auto level, commonly used on building sites because it's easier to set up and use. It has an internal compensator, can automatically level the instrument. It measures the difference in elevation between the line of sight and a point. Other equipment, the leveling rod, huge ruler, nothing more. Other equipment often used in conventional optical surveys are this leveling rod, a tripod, a professional tape measure, and a field book for recording your measurements. The tripod supports the surveying instrument. The tape is used to measure the distances, and the leveling rod is used to measure vertical distances with optical equipment and looks like an extra long measuring stick / ruler. The field book is used to record the measurements and observations taken during a survey. GPS technology taking over absolutely everything in the world. The GPS system can be used for surveying as well as navigation. GPS systems are a free-to-access system developed by the United States Department of Defense. Consists of a constellation of many satellites that orbit the Earth, each broadcasting a unique radio signal. GPS receivers determine the distance to each satellite based on the time it takes the signal to reach the receiver. The location of the receiver on Earth can be determined from as few as 3 satellite signals. Multiple satellites are always accessible from any point on Earth at any time. The top picture is a NASA image of one of the GPS satellites. Bottom image shows a moment in time when a GPS receiver on Earth has access to 12 satellite signals. As the satellite orbit and the Earth spins, the number of visible satellites from a location change. Some recreational GPS navigation units only calculate horizontal positions, latitude and longitude, and superimpose the location on a map image. These units do not need a high degree of accuracy and may calculate the location to within a few meters, close enough to determine which road you're on at least. Other handheld GPS receivers like the one pictured here on the right side provide both a horizontal and vertical position in terms of latitude, longitude, and elevation. The accuracy varies within the unit. The professional grade GPS surveying equipment like that shown in the left image provides a much higher level of accuracy than the lower cost recreational units. It calculates both horizontal and vertical positions to a high degree of accuracy. This surveyor is setting up GPS surveying equipment which includes an antenna, a GPS receiver, and a remote receiver. Before using the auto level, the instrument should be leveled so that when the instrument is rotated, the line of sight defines a horizontal plane. The leveling screws allow the surveyor to adjust the alignment of the instrument to provide a horizontal line of sight. If properly calibrated, the instrument will be level when the bubble in the bullseye level is within the circle. The mirror will reflect the bullseye level when viewing from the eyepiece height. The sight can be used to roughly align the telescope with the rod position, and then rotation of the horizontal tangent knob results in a fine adjustment. The horizontal rotational swing is used to approximate horizontal angles. Rotating the diopter adjusting ring, which surrounds the eyepiece, can sharpen the crosshairs when viewed through the eyepiece. When examining the rod to determine the increments used, the red numbers indicate whole feet, and they actually measure a true 12 inches. Each foot's broken up into 10 number divisions. The black numbers indicate tenths of a feet, though. Each tenth is further divided into 10 increments, which are indicated by the edges of the hatch marks. You'll have to get used to counting the edges of the lines instead of the lines themselves. The tenths of feet and measurements that end in 5/100ths of feet are indicated by the long edge of a beveled hatch mark. What measurement does this horizontal crosshair indicate? This means that the line of sight on the instrument is at 5.25 feet above the point on which the rod itself is resting. This is assuming you're looking through it. You'll notice that the stadia hairs can also be read. What's the upper stadia reading? 5.3 feet. Lower stadia reading, 5.2 feet. The estimated distance. Distance to the rod interceptor minus that. Stadium multiplier typically equals 100, indicated on the side of the instrument case or the instructional manual. So this would be 10 feet. Using the stadia readings, you can estimate the distance between the instrument and the rod. Differential leveling. If you start with a point of unknown elevation, such as a benchmark, you can determine the elevation of another point using differential readings. You start with the point of the known elevation as a benchmark. This isn't going to make sense to you without us being able to walk through this. I apologize, guys. Without us being in person, some things, normally we would set this up in the class and we would walk through this together. It's actually a pretty cool activity. Some of these learning aids just do not work for remote learning like this. Anyways, that covers the basics of the purpose of surveying and what we use it for, and how it's used in the civil engineering and alongside the architectural career paths. Okay, for the rest of today, I want you to get caught up on your plumbing plans and electrical plans. Both of those should be caught up. Only a couple of you are 100% complete though. Catch up your engineering notebooks with the concepts and essential questions I posted for today. Send me a link back to your engineering notebook and contact me with any questions. All right? I'm out. See you tomorrow, guys.